Hey guys, welcome back. We're going to continue working through our cumulative review. We're going to look at the stoichiometry section and try and keep this brief. All right, so we have our balanced equation. The question is asking for how many moles of water would be produced if 14 moles of oxygen gas react. So as we look at stoichiometry, remember, we have our handy-dandy Stoic Island diagram. So here we are going from moles of one substance to moles of another. So you're always looking at substance A, which is a known, going to substance B, which is your unknown. That's what you're looking for. All right, so we're going to set this up. You always set it up with what your known is. Do not forget to include your chemical formula, as that helps you organize your thoughts. So I have moles of O2 here. On the bottom, I also need the unit, moles of O2. And that's what I'm given. And on top, I'm looking for moles of propane. Process of elimination tells us that this C3H8 thing is moles of propane. And I'm missing some numbers. So remember, in stoichiometry, you are looking at mole ratios. That is the most important thing. So we have 5 moles of O2 for every 1 mole of C3H8. So we're essentially just dividing 14 by 5. That gives us an answer of 2.8 moles of propane, C3H8. Easy peasy. All right, we're going to do one more. We'll do number 7, and then I'll guide you in the right directions for numbers 8 and 9. So number 7, we are looking for liters of carbon dioxide. We are given 12.1 grams of propane. You always start with your known. So I have 12.1 grams of propane, propane C3H8. Now when I look at this again, I have my Stoic Island sheet. I am starting with a mass. I am trying to get to a volume. So this is going to be a 3-step problem. Review your steps if you forgot how to do them or where the conversion factors are coming from. All right, so I know that the molar mass of propane is 44.1 grams. That is equal to 1 mole of propane. Remember, it is very important that you are writing down your actual chemical here. We are trying to get to information about carbon dioxide. So in this middle step, I am converting from one substance to a new substance. Here we look back at our balanced equation. This is there's 1 propane molecule for every 3 molecules of CO2, or 1 mole of propane for every 3 moles of CO2. So 1 mole of propane needed to produce 3 moles of CO2. Our last step is converting to liters of carbon dioxide. 1 mole of carbon dioxide is equal to how many liters? I forgot. All right, here we go. Also on the back of your review packet, there's a whole bunch of equality statements. They'll help you figure that out. So as I do this problem then, I'm just going to multiply across the top, divide by the bottom. So 12 here. This is what it's going to look like on my calculator. Let's see. So 12.1 times 3 times 22.4 divided by 44.1. If I had more things to divide it by other than 1, I would just continue hitting the divide it by button. Or you could use parentheses, whatever you're more comfortable with. I get 18.44 liters of CO2. Remember to double check your work as you go through, that your units are canceling out. That kind of tells you, hey, you're finding what you want to find. Did I do that right? Did I do that right, Mr. Bartlett?
I don't know. It could sounds pretty good to me, Mr. Bowers. Your units all cancel. Kept track of your work. It's good.
All right, number 8 is a mass-to-mass problem. So again, number 8 is also going to be a 3-step problem. You guys can do that one on your own. The answers will be uploaded on the Haiku a little bit later. Last problem, number 9, it talks about theoretical, and you do a lab and you actually only make 11.5 grams of stuff. You know, what's going on there. All you have to do for that is plug in a couple numbers, and if you look at the back side, you'll just be using this percent yield equation. See ya.